Hi everybody, thanks for joining us today and welcome to Logicmonitor's 201 Advanced Webinar Series. My name is Sarah Terry and I'm a technical writer here at Logicmonitor. I also have Mike Arisic, one of our senior applications engineers, here with me. And this is the second webinar in our Advanced Webinar Series. And today we're going to be talking about how to monitor a device using SNMP. So I'm going to start by sending out a polling question to try and get a feel for everyone's experience levels when it comes to SNMP data sources. So we'll give you about a minute or so to respond to the poll. Everyone on this call today is probably at least somewhat familiar with SNMP and how it works in general. And today we're going to try to give you a better understanding of how SNMP works within Logicmonitor's architecture. As a side note, our founder, Steve Francis, recently wrote an ebook called The Comprehensive Guide to SNMP. And if you haven't already read it, you can download a free copy from blog.logicmonitor.com. And just so that you all know, we're going to be recording this session, so you will all be emailed a link to the recording following the webinar. So in today's webinar, we're going to cover a quick review of some of the basic SNMP terminology and the acronyms referenced when discussing SNMP. We'll give a reminder of what Logicmonitor data sources are. We'll go over what characteristics go into making a good Logicmonitor data source. We will discuss the difference between single and multi-instance data sources. And then we're going to go over how to make your own SNMP data source. And we're going to actually walk through this process with an example. And then we'll have a Q&A session for any questions you guys may have. So this may be a review for some of you, but let's quickly go over SNMP terminology and some of the acronyms we reference when we're talking about SNMP. So first, SNMP itself. This stands for Simple Network Management Protocol. SNMP is supported on practically all network equipment, but it's actually moved beyond that, and a lot of other devices also support it in at least some capacity. A MIB is a Management Information Base. And so basically this is a file in a tree structure that describes various objects and the information that's available about them. And then OID stands for Object Identifier, which locates an object within the MIB hierarchy. And there are two main methods of information transfer in SNMP traps and SNMP polling. A Logicmonitor data source will always use SNMP polling, meaning the collector will periodically query an OID and get back a value. So Logicmonitor data sources define what we monitor, including the type of device, the list of instances, and the individual metrics that will be gathered. And then data sources also define how we monitor these metrics for these devices. And this includes both the method for discovering the instances as well as the method for collecting the data. And these two methods don't always have to be the same, but we'll discuss that later in the webinar. And of course today, since we're going to be focusing on SNMP data collection, we're going to look at collecting data using SNMP. And lastly, data sources define how the collected data will be presented to users. And the main way Logicmonitor displays data is in graph form, but there are data points that are used to collect data for the purpose of alerting, and the conditions that define when alerts will be triggered are defined in the data source definition. So when we were preparing for this webinar, we looked through all of our open SNMP data source requests to try and find one that would make a nice, clean, and straightforward example, and that would illustrate all the important factors that go into SNMP data source development. But the more we looked, the more we realized that every single one really has to be treated differently, which is why this isn't a process that we can ever fully automate. There isn't really a one-size-fits-all approach when it comes to creating an SNMP data source. However, we do have some general guidelines that we try to follow when we're creating data sources internally. So first, the data sources should be reusable. We don't often do one-off data sources, meaning a data source that could only be useful for one particular situation. A well-designed data source can work with a range of devices and will be useful to numerous clients. So for example, our data source developers try to use tokens rather than hard-coded values as often as possible. Data sources should be customizable. We create data sources in a way that they'll work out of the box for the majority of use cases, but end users should be able to adjust them when needed. Data sources should be understandable. So the developers think about things like, is this the simplest way to get the desired information? Are the names, descriptions, and alert messages intuitive? Do the instances represent entities that end users will immediately understand? And then lastly, data that we're monitoring should be actionable. And this means thinking about things like, is this worth monitoring? Is it exposing useful diagnostic information? Are each of the data points being used for a purpose? So either in a graph for an alert or referenced in a calculation on another data point. And one of the main decisions that the data source developers have to make is how to best construct the data source to work with Logicmonitor's instance-based architecture. So a data source can be multi-instance, single instance, or not have instances at all. For example, consider a Linux server. Let's say we have a quad-core CPU processor and want to monitor the CPU busy percent. We can get the busy percent for the quad-core CPU as a whole, or we could get it for each individual core. In the latter case, we'd have a multi-instance data source with each core as an instance. And this works best if the MIB is organized in a way that lends itself to this model. We wanted to walk through the full process we go through when creating new SNMP data sources internally. And we actually have a device in our internal lab environment that we didn't have data sources for, so we decided to use it as an example for this webinar. The first step in creating an SNMP data source is to get the MIB for the device you want to monitor. So the first thing we did was a quick Google search to see if we could find the MIB online. When a customer submits an SNMP data source request to us, we always ask them to provide a copy of the MIB if at all possible. Some companies are really good about keeping MIBs online and publicly accessible, but it always makes it easier for us if the customer can give us the MIB. So the data sources we are going to create today are for a WTI switched PDU. And here we are on the manufacturer's website. So you can see that in this case, the MIB is online and pretty simple to find with a quick Google search. The other useful thing is that we can see a picture of the device. And that may not seem like it would matter, but it's actually really helpful to be able to visualize the device and get some kind of idea of what components it has. So in this case, it's actually in our lab, so we could see the real thing. But when we're developing data sources for customers, the equipment is in their environment, and we don't always know exactly what it is. So having a visual really helps us figure out how to structure the data source instances in Logicmonitor, like we talked about earlier. So in the image of this device, we can see there are 8 plugs. And we know right off the bat that we're going to want to monitor metrics like current, power, voltage, temperature, etc., like we do for other power distribution units. So we went ahead and downloaded the MIB and loaded it into our MIB browser before the webinar to save a little bit of time. The MIB browser that we're using is called the iReasoning MIB browser, and this is the one that most of Logicmonitor's data source developers really like to use, but any MIB browser would probably work just fine. So the first part of data source development is to browse through the MIB and figure out what information is exposed and how it's organized. So you can navigate down the levels of the MIB tree, and the first thing that we see in this MIB tree are tables with plug information. So it looks like we've got plug IDs, current, power, and a couple of other metrics. Now not every device will report every metric in the MIB, so we want to make sure that our device actually reports data on these OIDs. And the way to do that is a quick test on these OIDs just to see what we get back. And you can actually manually run an SNMP walk or an SNMP get from the Logicmonitor collector. And I'm going to go ahead and show you guys how to do that in case anyone on this webinar isn't familiar with the collector debug facility. So first you obviously need to add the device into your Logicmonitor account, which we've done already with our PDU. And then you want to figure out which collector is monitoring it. And you can do that by hovering over the device. So we've got collector 83. And then we'll find collector 83 in the settings tab, click the wrench icon and choose run debug command. And the debug console is basically a way you can have the collector run various commands to the devices it's monitoring, and this will let us know exactly what data is exposed by the device and available to the collector. So let's first walk the plug ID OID, and the syntax for that is !SNMP walk, and then the host name, and then we'll just copy and paste the OID value from the MIB tree into the collector debug command line. And as a side note, you should use the IP address as the host name if the host has been added to Logicmonitor using its IP address, and use the DNS if the host is in there by its DNS. And when you're using the debug facility, the collector will apply the SNMP community string that's set up on the host. So you can see that this SNMP walk returned different leaf values for the plugs on our device that have an ID. So we got 8 plugs returned, 4 A plugs and 4 B plugs. Now let's try walking one of the other OIDs. We'll try plug status. So we do the same thing, SNMP walk, hostname, status OID. And we expect to get 8 status values, 1 for each of the plugs. And yes, there you go, that's exactly what we see. We can see that 2 of the plugs are on and 6 are off. And normally, the MIB will actually tell you a little bit of information about the values you're getting back, things like unit of measure, or what the various status values correspond to. In this particular case, it doesn't really tell us a whole lot, but it's pretty standard to assume that 1 corresponds to on and 0 to off. So if we wanted to get a status value for just one of the individual plugs, say the first one, then we would just add the leaf value for that plug onto the end of the OID we walked. And remember that the leaf value is the first number you see in the results. So we want a leaf value of 1 in this case. And we'll use an SNMP get instead of SNMP walk. So we do SNMP get hostname OID plus the leaf value, and we get a status value of 1 for that plug. And so the status value is something that we would probably want to have in a data source. So now that we know that this is all working, and we've successfully done an SNMP walk and gotten back values from our device, let's put all this into a data source. So on the Settings tab, select New Data Source. And in our internal data source development guidelines, as a best practice, we recommend that the name be very specific and mention the type of device. So we'll call this one WTI PDU_status. And the display name can be simpler. We'll just give this one a display name of plug status. And since we do have multiple plugs and we want to know the status for each one, we're going to make this data source multi-instance, and each plug will be an instance. Now we talked about single versus multi-instance a little bit earlier in the webinar, so for now let's just move on to the Applies To field. As a best practice, when we're developing a new data source, we only want to apply it to one device, and after it's completed and tested and we know it's working, then we can apply it more broadly. But right now we'll enter an Applies To function based on the name of our device. We can just leave the polling interval as is for now. You can always leave it as is and then come back and adjust it based on the data you are getting. We will enable active discovery, and basically this is going to tell the collector to discover the instances, which are the plugs, based on the information we provide. So if you remember, we found all of the plugs by their unique IDs when we walked the plug ID OID. So we're going to use that as the SNMP OID. Now the SNMP OID has to be some kind of identifying information, and it has to be consistent. So sometimes it can take a while to figure out what OID to use to discover the instances, and sometimes there will actually be more than one that would work. So it comes down to a matter of preference and your use case. And then when this data source applies to a host and the instances are discovered, they're going to be labeled using whatever is returned when we walk this OID. So we try to make it something that's user-friendly and easy to understand. And then you also have the option of using a description OID, and that's something that could be appended onto the instance names. If you remember, there was another OID in our MIB that looked like it might have some name information, so maybe we can use that for the description OID. Let's try walking the plug name OID. So we'll go back to our collector debug. We'll do SNMP walk, host name, and then the name OID. And while it looks like that request timed out, which is not completely surprising, it probably just means that this device doesn't actually report data on this OID, which of course means we can't use it to identify our instances. So since we know the plug ID OID returns data and gives us pretty good identifiers for our instances, we'll just use the plug ID OID for the SNMP OID. And we can just copy and paste that directly into the data source definition. And then the description OID field is optional, so we're not going to use it here, but just to give you some context, we will show you a data source that does have a description OID, and here's what the instances look like when there's a description added to the instance names. So the first part is what we've gotten from the SNMP OID walk, and then the second part in the parentheses is what we got for the description OID walk. And then before we go on to create our data points, which is where we will set the information we want the collector to gather for each instance, let's talk briefly about setting persistence on a data source. Whether the data source should be persistent depends on what kind of objects your instances are. If they are a fixed set of things that's not going to go away, like our plugs in this case, then generally you should make the data source persistent. If, however, your instances will come and go, then generally you shouldn't make the data source persistent because the set of instances may change periodically. So since active discovery runs periodically, the persistence setting determines whether a discovered instance should be removed from the instance list if it doesn't respond when active discovery runs. If you guys have any questions about persistence and how that works, just type it into the question box in the GoToWebinar interface and we'll cover it during the Q&A at the end of the webinar. So let's create a new data point and call it status. And we'll add a description that indicates that this value reflects the status for each plug, and that a status value of 1 indicates that the plug is on, and a status value of 0 indicates that the plug is off. And then the OID value we want to specify for this data point is going to be the OID we use to see all of the plug statuses. However, each data point has to be an SNMP get and return exactly one value, meaning we need to set this up so that we get a value for each instance, so each plug in this case. And instead of adding 8 separate data points, one for each plug status, we can add one data point, and instead of hard-coding a particular number or a particular leaf value at the end, we'll tell it to use our instances by entering pound pound wild value pound pound like this. And we'll leave the interpretation method as use direct output, which means it's going to use the exact number it gets back from the device, rather than doing some kind of calculation or conversion on it. And then because we know the status value is either going to be a 0 or a 1, and nothing needs to be interpreted from these values, the direct output is going to work just fine. So we'll leave the metric type as gauge, and the metric type should reflect the type of data you're getting. And we'll talk about the different types of metric types and when to use each one a little bit later in the presentation. But in general, I'll just note that if you're ever not sure what metric type to choose, just leave it as a gauge and start collecting data, and you'll be able to tell pretty quickly whether or not you need to go back and adjust that metric type. And then we don't want to set any alert thresholds until we've finished writing all of the data sources for this device and until we've monitored the incoming data for a while. So let's submit this data point, and let's also submit the data source. And then we can navigate to the Devices tab and make sure that it's applied to our device. So there it is, plug status, and it's probably going to take a few minutes to get enough data to look at, so we'll come back and look at this in just a little bit. So going back to our MIB browser, we can see what other information we can get for this device. So we see these current and power values. Let's try and walk those OIDs. So we'll navigate back to the collector debug and do an SNMP walk, hostname, and then the OID for current. And it looks like that walk timed out. So let's try the power OID, and we'll do the same thing. We'll do an SNMP walk, hostname, and then the power OID. And we get another timeout. And so what this means is that this information probably just isn't available for this device. And that does happen sometimes. Manufacturers occasionally have one MIB for multiple types of devices, so not all of the metrics are going to be available from all of the different devices. In this case, it doesn't look like this device is going to give us per plug current and voltage information, at least with these OIDs. So we'll keep looking through the MIB to see if there's anything else that looks interesting that we might want to monitor. So let's look at this environment unit table and see what's in there. We can see here that we have name and temperature information, and then current, voltage, and power information for the A branch, B branch, and so on. Now we're already pretty sure that our device only has A and B branches because when we looked at the plugs earlier, there were only A plugs and B plugs. And so even though this device didn't seem to give us per plug voltage and current metrics, we might be able to get some aggregate voltage and current metrics for each branch. So let's try and walk the environment unit name OID. So that's SNMP walk, hostname, and then the name OID. and we get back 4 leaf values corresponding to 4 environment units. So now we can try a walk on the temperature OID. And we expect to get 4 values back again, a temperature for each environment unit. And that's exactly what we get. However, we see that only one of these leaf values corresponds to a non-zero temperature, which means that really we're only interested in that leaf value or that one environment unit at this time. So if we walk the OID for the current through branch A, we would expect to only get a non-zero current value for the one environment unit that's giving us a non-zero temperature value. So let's try that. And that's exactly what we see. And then we could also try power and voltage, and we'd expect the same results. And then this means that we can expect the same thing to happen for branch B as well. We will only get current, voltage, and power metric values, or non-zero values, for one environment unit. And this means that for each of branch A and branch B, we have voltage, power, and current for a particular environment unit. And then we also have a name of that environment unit and the temperature for that environment unit. So how do we best represent this information in terms of Logicmonitor data sources and instances? And this is one of the things that you oftentimes have to think through when you're creating data sources, deciding how to organize the data you're able to get from the MIB. Now we already know that the instances are not going to be the 8 plugs, but rather the environment units, which means that we'll need to create a second data source rather than adding additional data points to the first data source. Now it would be ideal for creating this data source if the MIB instead gave us an OID for the current, voltage, and power metrics through the one environment unit, and then the leaf values would correspond to branches A and B. And that would allow us to set up a multi-instance data source with current, voltage, and power data points that use a wild value, just like we did for the status data point. In this case, however, the best way to organize the information for these metrics is to create a current data source with data points for the current through branches A and B, and then we'll do the same thing for power and voltage. So let's add a data source and name it WTI PDU_current. And then we'll set the display name to branch current. And we'll make it multi-instance, and then we can make the description current through branches A and B and C and D, so just current through the branches. And then we will enable active discovery, and we'll use the same applies to that we used before based on the host name. So we can use the environment name OID as the SNMP OID field, because this is the best identifying information that we have for the different environment units. And this will make more sense in just a moment when we create our data points. So we're going to create 2 current data points, one for branch A, and we'll name it current A. And then we'll copy the description of the branch A current OID. And then the OID is going to be this branch A current OID. So we'll just copy and paste that, and then we'll add a wild value at the end, which is going to give us the current through branch A for each environment unit. But as we previously specified, we're not really interested in the non-zero or in the current values that are equal to 0. So we'll save this data point, and then we'll add a filter that tells the collector to ignore all values that equal 0. So we add a filter, and the values we want to filter out are the 0 current values. So the attribute we want to check is the OID for the current through branch A. And then we'll set the operation to not equal and the value to 0. And because we want to filter out all current values equal to 0, and as a best practice, it's usually a good idea to add a filter description that makes the filter as transparent as possible to other users in the account. So we'll submit that, and then we'll create an identical filter for the current through branch B. So we'll do the same thing. We'll use the OID for the current through branch B from our MIB browser. And then we'll do operation not equal value 0. And that should leave us with one data point that reports the current through branch A for our one environment unit, and then another data point that reports the current through branch B for our one environment unit. Now we're not going to go through it right now, but we would want to do this same thing for the power and voltage data sources. So we can save this data source, and then remember that we also have the temperature of the environment unit. So we should create a data source to monitor that value. So let's call it WTI PDU temp, and then we'll just make the display name temperature. And even though we're only getting data for one of 4 total environment units, we'll still make this a multi-instance data source just like the current data source, because then it will discover everything and filter out the temperature values that are equal to 0, just like we did for current. And that way, if the other environment units ever did start reporting data, we would get that data reported in this data source. And we want this to apply to our device, so let's use the same applies to function as before, based on the host name. We will enable active discovery, and we can just copy and paste the environment name OID into the SNMP OID field, because as we previously established, this is the best identifier that we have for the different environment units. And then we'll create a data point for the temperature. So let's name it temperature, and we can copy and paste the description for the temperature OID from our MIB browser into the data source definition. And then we'll copy and paste the temperature OID into this data point definition, and we'll add a wild value at the end. And we'll just leave the metric type as gauge and the interpretation method as useDirect output, because we want the temperature value and it doesn't need to be manipulated at all. And then the last thing we have to do is create the filter that filters out the temperature values that are equal to 0. And we will do this just like we did it before, using the temperature OID. And sometimes there is a small glitch with the UI where it doesn't let you copy and paste things in, and we are working on fixing that. But when that happens, just submit the data source to submit any changes that you already have and refresh the page. So we'll search for the data source that we were editing. We'll go back and add our filter, and the attribute we want is the temperature OID from our MIB browser. And then the operation is not equal, and the value is 0. And then we can submit this data source. So let's navigate over to the Devices tab and look at the data sources that we've just created. So you can see the branch current, plug status, and temperature data sources that we just created. And if we open up the plug status, you can see that we're probably already getting data. And so when you create data sources, if you don't create any graphs, there is a default overview graph that displays lines for all of the data points. So if we open up the branch current, you can see that we have an overview graph here with a line for current A and a line for current B. Now, let's say we wanted other graphs to display. We can create graphs for the current. We could create one with one line for current A and one line for current B, even though that's already what we're seeing in the overview graph. And the way that you would do that is you just go to the data source definition and select new graph. And then we'll just name it current. And the vertical label, we would like the vertical label to be in amps. If you recall from our MIB browser, the current OID values actually report data in tenths of amps, so we will need to adjust the values that we are getting back in order to display this information in the unit of amps. So we're going to add the 2 data points that we have, current A and current B, and then we'll create 2 virtual data points. And the virtual data points will allow us to divide our current data points by 10, and that way we're reporting current in the unit of amps. So the graph lines that we're going to want to display here are going to be the virtual data points that we just created. And then we can also make these lines different colors so that we can compare the different currents through these different branches. And then ideally we would go through the same process for the data points in our power, temperature, and voltage data sources. But again, we're not going to go through all of that right now. So we'll submit this, and that's how you add a graph to your data sources. So we made data sources for our PDU based on the best way that we could organize the information in our MIB, but now I'm going to show you what our data source developers would have done for this device. So earlier in the webinar I said that you could make the active discovery method different from the data collection method, and that's actually what our data source developers would have done in this case. So the information in the MIB wasn't organized as ideally as it could be for Logicmonitor data source instance creation because branches A and B are two separate instances of the same kind of thing, but the MIB doesn't present them as part of the same table. So it might make more sense to express them as separate instances. And so what our data source developers did was use a simple embedded Groovy script to reorganize how the data was discovered. And so the way this works is you can write a Groovy script to do the SNMP walks and print information in a particular format. And then Logicmonitor will interpret the printed data based on an expected format, and that way you can control what Logicmonitor uses for the wild value by changing how you print the information from the script. So in this case, we were able to use an embedded Groovy script to discover local branch A and local branch B as instances for our current data source. And if you recall, the best way we could organize the information without the script was to discover the environment units as the instances of the current data source, and then discover 4 data points for each of these discovered environment units and filter out values equal to 0. So the script allows us to display the information in a slightly more convenient format. But again, the way you decide to create your data sources comes down to your use case and really what works best for you. If you guys have any questions about how we implemented this script active discovery, feel free to ask a question in the GoToWebinar interface or reach out to us after the webinar. So because there isn't a one-size-fits-all approach when it comes to creating SNMP data sources, we can't leave you with a comprehensive set of instructions that will take the guesswork out of SNMP data source development. We can, however, give you a quick recap of the steps you should take to create an SNMP data source. So first you should identify a need. For example, if you have a problem in your network, you'd want to figure out a way to prevent it in the future. So you could create a data source capable of detecting the condition in advance. Next, you'll need to do research. What are the typical things you would look at for your device? You want to try to get as much information as possible. You can even try Googling the phrase monitoring followed by the name of your device to try and find MIBs and best practices, and then look through the MIB and find out what metrics you can get. And one of the things that you want to figure out here is what are the possible scenarios where things can go wrong with the device? What problems can occur? And how can you prevent these problems? And then next you're going to need to come up with a way to monitor it. Are you going to need one or more data sources? Will they be single or multi-instance? And then you can build a prototype. And remember that building a prototype includes creating the data source and identifying information to get performance information. And the identifying information will be your SNMP OID. So you'll want to walk the OID that looks most promising as far as identifying information goes, and then hopefully you get back something with at least a few leaf values, and you can pick one or more metrics that you want to monitor. Now remember that not everything in the MIB will be useful, and you should only monitor things that are worth monitoring. So then you can add a data source that has a data point for the one or more OIDs you picked out from the MIB. And then the last thing to do is just wait and collect data for a little while to verify that everything is working and that your numbers make sense. If everything looks good, you can start applying the data source to other devices. And that concludes the content for today's webinar, so I'm going to hand it over to Mike for the question and answer session.
Okay, so we actually had quite a few questions related to the Groovy script that we showed briefly. I think what we're going to do is actually provide a copy of that script to anyone who's interested. We can send that out after the webinar, and we'll send a little bit of a more detailed explanation written out. Mike, do you have anything to add to kind of explain when we would know that we'd want to use something besides SNMP for the discovery, like a script?
So the standard SNMP discovery does a walk of one OID and gives you all the objects that come back from that walk. When you would need a script would be when you need to do something that is more complicated, that like if you needed to concatenate two names together, or in this case, if you had a set of OIDs that did not fit neatly into a tabular format and you wanted to break them out into instances. Most things that are SNMP, however, can be done with standard SNMP discovery and the filters.
We had a couple of questions about the persistence. We talked very briefly about that, but can you give us some kind of generalization for when the data source would be persistent versus not persistent?
So the persistence checkbox is there because our discovery process is designed to in an automated way, maintain your instance lists. So the discovery can both find instances and in some cases get rid of instances. So the most simple explanation is that if there's an object that can appear and disappear without any negative consequences, then you don't mark it as persistent. One example of this we use is in our ESX hosts. We have virtual machines. It's perfectly normal to spin up a virtual machine and spin down a virtual machine, or move a virtual machine from one ESX server to another, in which case it would disappear in one place and appear in another without any incident. And you should be monitoring your VMs as hosts anyways, so you don't need to raise an alert if one disappears, because you would know if it was a problem. Something where it would be persistent would be a network interface. Most network interfaces, we start out with none of them there, and we have filters so that any down interface doesn't actually show up. But then once you plug something into the switch, like let's say it's a switch, then it will pass the filters and show up. You want to know if someone comes along and unplugs something that's been plugged in. You wouldn't want it to simply disappear next time Active Discovery ran automatically. So we have that set up as a persistent data source with an alert on one of the things that it filters on, which would be the status.
Can you elaborate on when you would want to make a data point a derive rather than a gauge? And that was something we kind of mentioned, but can you expand on how you know when to change the type?
Sure. There are two main ways SNMP data points can present data. One of which is a counter, which is a continually incrementing value. An example of that is the way that SNMP exposes byte counts in and out of interfaces. Those numbers are like an odometer. They go up and up and up, and they never go back down, and you can measure them at various points. And what we do with our derive is we calculate a rate of change of that so that you don't have to worry about the underlying math. Another example is the gauge, and that's something like maybe disk capacity or disk usage or temperature, something like that can go up or down and is not a one-way thing. And those tend to be instantaneous measurements of some particular value. And so practically speaking, also, when we're building a data source, one of the things that we sometimes do is we'll just set everything to gauge, and then you can see that anything that really is a gauge will either stay flat or go up or down, but values that should be derived tend to climb and climb and climb and climb to the right. And then we know that those are good candidates to make derives. Obviously, you can sort of look at the data and see what it is and make that decision at first, but sometimes there's a question, and you can use that as a pretty easy way during prototyping to sort it out.
Okay, and another question about the OID section in the data sources menu. There's a section called OIDs, and then what is the purpose of this page basically compared to OIDs in the normal data source view? That would be the OID to category mapping table. Can you explain what that's in there for and how we keep it updated?
Okay, so there's a set of, one of the ways that we apply things is by device families, and those tend to run, there's a value that's reported by most things that's, well, actually everything, called the sysoid, and in some cases it actually describes very accurately what the device is and where it lives in its family tree. And so we actually attach categories through a matching process to those. And that way we can get more and more specific with what data sources apply to what devices.
Perfect. Any last questions? Please feel free to just type them into the chat box and we'll be happy to answer them. Otherwise, we will go ahead and send a copy of that script along with a few follow-up notes after this webinar, and the recording will be posted as well. All right, well, I think that will wrap it up for today. Thank you so much for attending, and feel free to email us afterwards if you think of any other questions that are related, and we'll be happy to help.
We'll keep you guys updated on the topic for next month's advanced webinar as well.